Hey guys, welcome back to my channel, on which in the previous videos we were discussing about we discussed till 1.3 exercise of our first chapter, number system of 9th standard NCERT syllabus. Now we are continuing with the next part, that's 1.4 exercise, that is representing a real number on a number line. We learned what is real number is. Real number is consist of a number system. Real number is a number system which consists natural number, integer, whole number, rational and irrational. Now in this current exercise we are supposed to visualize a given number in a number system. Visualization is the concept here. See, I am going to visualize 2 point, yeah, now you can see I am going to visualize 2.65. See, there are several examples given in your textbook. I am not going to do everything because this I am not going to do only in this exercise. I am not going to do everything because this is quite easy. If you focus on only one example, you can do rest all. And this is one which you know. This is not need not to be to tell you. We need not to teach you again and again. But this is quite often you know. But you should recognize with a confident. That's required. I am going to represent 2.65. I am going to visualize 2.65 on a given number line. See, 2.65. First step, where 2.65 lies. It lies between 2 and 3. That's known. So if it lies between 2 and 3, it's better if you take a scale of 0 to 5. If you take 0 to 10, good. More than that is not required. Unnecessary things are prohibited. That's not good. Okay, 2 and 3 is best. 2 and 3 is what we consider. 0 to 10 is best. See, this is something like what you zoom in your mobile phone or tablet. You just zooming in the things to visualize what is there within that. This is just normal scale representation. You are supposed to locate 2.65. 2.65 lies between 2 and 3. First point, check out where 2.6 something lies. Check out in the scale where it lies between. You need to check where is the one end and the other end. You need to point the first end A, let us take second end B. You need to check that point. Here the point is 2 and 3. Cool. Now I hope you are familiar with this. Need to check out our endpoints, that's 2 and 3. Now going to the next thing, we zoomed in 2 and 3. We zoomed 2 and 3. This 2 and 3. We zoomed 2 and 3. Here you know in your normal scale. Let me show. Yeah, in your normal scale, you will see a centimeter along with. You will see a millimeter. You know that small lines are millimeter. That's what millimeter given here. You need to recognize 2.65. First thing 2. Here we need to recognize 2.65. 2 here done. 6. 2.6 that lies between 2 and 3. Next step, zoom in. 2 and 3, 10 parts divided each into 10 parts, that are 2.1, 2.2, 2.3, 4, 2.5, 6, 2.6, 2.7, 2.8, 2.9, 3. 2 in between this 2 and 3 we divided into 10 parts. Okay, the next what we want is 2.6. 6 is here. Okay, next we got 2, we got 6.6. Next we need to find 5. We need to visualize 5. That's done in the next zoom. Here what I did is, we know we got 2.6 in our second zoom, second visualization. We need to find 2.65, and we know here 2.65 lies between 2.6 and 2.7. Now our A is 2.6, our B is 2.7, one end, other end, zoom in. That is this. Here what I did, 2.6 one end, 2.7 other end, again 10 parts. Next, the next digit is converted, the next digit is represented here. It is represented in 10 equal parts. That is 2.61, 2.62, 2.63, 2.64, 65, 66, 67, 8, 9. There is no concept of 10. That's next thing is 2.7. Here we need to find 2.65. We got here. This is the visualization. We found 2.65 here. This is done with our concept. That is what visualization is. If there is any number extra, 657, let us think there is a number 2.657. What you need to do is, this is 2.65, this is 2.65, this is 2.66. You know 2.65 lies between 2.65 to 2.66. Take 2.65 as A, 2.66 as B. Zoom again. Divide it by 10 parts. You will get 2.67. Same as you if you divide it like this, you will get 2.67 in that image. This is so simple. So I dealt with a single example. See, I will give you a hint for your example problems. There is an exercise problem. The first question is of 3.765. Second question is of 4. This is question number 4.26, and 26 is given with a bar which is repeating. Now this is simple. 3.765. First 3. You need to make, where will be the 3 on a number. 3.7. 3 first A. 4 is B, 3 is A. Divide 3.1, 3.2, 3.3, 4, 5, 6, 7. This is 3.7. Next number is 6. Zoom. 3.72, 3.8, 3.71, 3.72, 3.73, 74, 75. 75 is large one. 76, 76 we need. This is 3.76. Next thing is 3.765. Take, this is 77. Take next 3.76. This is next thing to 3.77. Divide 3.761, 762, 763, 764, 765. This is 3.765. You need to visualize this in a good neat manner as I did this for this. Here also same thing. Take 4, 5. Divide 10 equal part. Second number is 4.2. You got one digit after a decimal point. Again 4.2 to 4.3, you get a 4.26. Go on continuing. I hope you can do this. This is quite simple, and this gives the end of 1.4 exercise. I am going to conclude the concepts of 1.5 in this video itself. Let me change my page. Yeah, we landed on exercise 1.5, operation on real numbers. Operation on a natural number, whole number is quite easy. How quite easy in the sense, let me give you natural number. 1.1, 1 plus 1, 2. 0 plus 1 is even easier than this one. 1, this is whole number addition. Integer, minus 1 plus 1, 0. You learned all these stuffs. You learned all these things. Now the concept of operations on real number is to teach you how to do these operations such as addition, subtraction, multiplication, division on a real numbers, in the sense irrational numbers. You know the concept of square root that is taught to you in your previous classes. Square root is actually most number of square roots gives you what? Irrational numbers. It gives you irrational number. Here we are dealing with one such concept or operations. We are dealing only with addition and subtraction for your syllabus, as per your syllabus, and these are the formulas you need to remember. I will show you how to remember. How to remember is a technique you are supposed to know. And let us start. See with the first thing, this one. These things work only when there is a multiplication between two square rooted number. I will show you example. This is root 2, then this is root 5. Then according to this given sentence or equation, this is equal to a into b. A into b. Sorry, b is 5. Yeah. Root 2 5 is 10. This is the first equation. First equation tells, what it tells is a is different number, b is different number, and if you multiply this gives you a ab, root ab within the given square root. This is the first operation. What it tells here is, if even if the numbers are different, they can be multiplied within the single square root. This is the first concept. Second concept, nothing but dividing the, let me adjust my camera. Yeah. Dividing the number, two different number which are square rooted, can be represented within a single square root. I have an example here, root 2 divided by root 5. See, a is a different number, b is a different number. You can write this in a within a single square root, root by 5. This is simple. Actually what it tells is, root 4, think root 4 by root 2. You can write this as 4 by 2, which is 2 ones are 2 2s are root 2. This is what they are saying. You can give a single square root for both the different types of number. If I come to the third part, see everything, all these statements are stated in your textbooks. If I come to the third part, here root of some number, first number a, plus root of the second number b, they are in addition and multiplied with the root of third number, same the root of first number minus square root of second number, gives you a minus b. This is the one ready result. These are ready results. How? Question. I will prove one, and these statements proofs are not needed. You need to memorize this. You need to remember this. If you are well with mathematics, even remembering is not good. Not required. See, given, I will show you the proof of third statement. Root a plus root b into root a minus root b is given as a minus b. Now multiply each, multiplying, if a plus b, if 2 plus 5 into 2 minus 5, you know how to multiply polynomials or given such systems. Multiplying root a into multiply of the second whole term. Next thing is root b into root a minus root b. I multiplied this with this all and this with this all. I hope you know this. Now root a into root a, this concept, first concept, root a into root a is equal to root ab. Here, sorry, root a into root a square. Here, here 2 and 5 are different, but in here both are same, a and a. This gives you root a square minus, this is the second concept, different numbers. This gives you root ab. I hope you are clear with. Next, b into a, root ba minus root b square. B into b, b square. Square and square root cancel. Square and square root cancel. Fine. Square and square root cancelled. Now a remain minus root ab plus root ba is nothing but ab only. 2 into 5 is also 10, 5 into 2 is also 10. B only. C plus root ab minus root ab plus root ab. That's something like minus 1 plus 1, which is equal to 0. This cancels. Answer is A minus B. Now coming back again, this one such type. Here there is no root to here, root to the first number. A plus second number has root into a minus root b gives you a square minus b. Remember, here both the numbers have root, and the difference between this is both the term has positive, both are added. Here one is subtracted, and the answer gives you. And here 4 numbers, something is multiplied into some other, a, b or something, c, d or something. Answer is root of ac, root of ad, root of, an addition, root of bc, root of bd. Adding. Here, see why I am going fast with this is, you will come to know when you solve problems. That's quite easy. Root of a plus root of b whole square. A plus b formula, a square. Here a is root a, so root a square, square and square root cancel gives a, plus root b square, square and square root cancel gives b. 2ab, 2. A is root a, b is root b. Root a into root b gives root ab, first thing. Yeah, we are done with this. Now we will go to problems. You will come to good understanding if you complete problems. Yeah, I am going now with given example problems. See, I am not giving any problem for you. I am solving all the example problems here. Why? Because you are completely new for this such operations, and you need to have a good grip or good basics. So you need not to struggle in your first PUC or second PUC. I am the one who struggled actually. When I was in 9th, I didn't learn good basics. I was lacking with such operations, and after that I learned. So I know what the struggle you need to go with maths if you are not strong with basics. Now I am going to teach you the first example problems, getting into the concept. See, this is quite easy. A plus b, here they are different, into something c because different, plus root a. You need not to take a, b, leave all those things. One number plus another number into one number plus another number. What actually you need to do is, you need to consider normal multiplication. Take first number from first term, take the second whole term. You are familiar with this multiplication. Second number, root 7, and again whole term. I will explain you what I did. This is multiplication. This term is multiplied with first word. This term is again multiplied with second word. This whole term is multiplied with first word. Whole term is multiplied with second word. Good. Now normal multiplication. That's it. This problem is done. 5 2s are 10 plus 5 into root 5, 5 root 5. Here you need, here focus to be done. You are not going to write root of, you should not take this 5 inside the root. You should not going to write, you are not supposed to write root of 5 into 5. Okay, since this has no square root, you are not going to consider this inside this square root. We are leaving this outside that square root. Next, root 7 into 2, same thing. We are leaving 2 has no square root, we are leaving outside. Plus, this is of the form root a into root b, root ab, root 7 5, 35. Now this is our answer. See, I need to tell you something. If there is a, instead of 7 here, see, this is our first question answer. I am going to teach you something. That's a concept of like addition. Here, if this is 5. If suppose assume there is a 5 here, then you can add this. If root 5 and here also root 5, suppose 10 plus 5 root 5 plus 2 root 5 plus root 35. Suppose this equation was like this, then the final answer going to be 10 plus 5 plus 2, 5 plus 2, 7 root 5. Since root 5 and root 5 are same, you can add this plus root 35. But I am not going to consider this. Why? Because this is our given question. Going to the second problem. 5 plus root 5. Everything is same, man. Everything is same actually. First term, second whole full term, plus root 5 second term, again complete second portion. 5 5s are 25. Your basic mathematics. 5 5s are 25. Plus 5 into minus something is minus. 5 into root 5, 5 outside because no square root. Same, 5 outside. Plus into minus, minus. Root 5 into root 5. Here normal thing is root a into root a, but a are same, that going to be root 5 into 5, 25. You can also write, instead of taking root 25, you can also write 5 directly. Why? Because 5 into 5, 5 square, and square root and square going to cancel. Now 25, see, this same with opposite signs, this is going to cancel. Minus root 25. Root 25 is 5. 25 minus root 25, 5 gives you 20. Simple as your basic algebra. Now third question. This question you can recognize. This is of the form a plus b whole square. So simple, a square plus b square plus 2ab. You need to remember all those formulas for your whole entire education life. If you are pursuing any mathematics course within your education, then you need to remember all those things. That's quite necessary in everywhere. Even if you come to engineering, this simple formula is required. A plus b whole square equal to a square plus 2ab plus b square is compulsory. Now a square root 3 square plus 2a root 3 into root 7 plus b square root 7 square. This is what? A square plus 2ab plus b square. Our a is root 3 and b is root 7. I wrote all these things to make you understand, because you need to be strong in your basics. Okay, now moving forward is quite easy. Root 3 square and square root cancel. 3 plus here root a into root b, root ab. 2 root 3 7s are 21 plus square and square root cancel. 7 you can add 7 3 10 plus 2 root 21. So Zian, there is another example, fourth question. I am giving that as your homework. Why I am giving that is because that's simple as this question. Here only the numbers are changed. If you practice this, if you know this, and that question going to be dead easy for you. And moving forward, there is a concept of rationalizing the denominator for you. Let me adjust my paper for you. Yeah. See, moving forward, there is a concept of rationalization of a denominator. See, this is denominator. This thing can be anything. This is a numerator, this is a denominator, and the given denominator is irrational number. You need to rationalize the thing. You need to convert irrational number into rational number. What you are going to do? I will directly go with the solving steps that makes you easy with respect to other things. Now, the first question given for you is 1 by 12, root 12. Root 12 is irrational number. Sorry, given thing is not 1 by root 12, that's 1 by root 2, sorry. Make it as 1 by root 2. I will write once again, that's 1 by root 2 is the asked question. Even if the root 12 is not so tough, everything is common easy. See, we need to remove root square root here for 2. What we need to do actually is, say I will tell you the method. If there is a single number in your denominator, you know, if there is a root a, you need to multiply it with root a, so that you will get square root of a square, which is a. Can you get that? Can you get the concept? Yeah, here also same thing. You need to multiply root 2 with root a, root a with root a in the sense root 2 with root 2. And you need not to alter this equation. How that is done? Multiply both numerator and denominator. That is 1 by root 2. Multiply both numerator and denominator with the root 2. You can do this. Why we can do this? Even if we cancel this, the remaining is 1, and 1 multiplied this by this number gives you same 1 by root 2. So that's the reason why we can use, or you can multiply any number and also again dividing by same number. What happens here is numerator 1 into root 2, root 2. Same concept, root 2 into root 2, root 2 square. Now root 2 square, square root cancel. Yeah, we rationalized our given denominator. So simple. This is quite simple problem. Let me take the second question. Yeah, I am here with the more examples. See, you can see the denominator of 2 terms. The previous question was of only one term, that's root 2. Here there is a problem of 2 terms, and because of this root, this denominator is still irrational. You need to convert this irrational to rational. The same concept. There is a factor. Actually, there is a factor called rationalizing factor. What is rationalizing factor is RF. You need to multiply and divide by that factor so that your problem will not alter and you will get the rationalized denominator. If a plus b is in your denominator, then the conjugate of a plus b, conjugate in the sense inverse of a plus b, that is a minus b, is your conjugate of a plus b, and this is your rationalizing factor. You should multiply and divide by this factor so that you will possible to rationalize the denominator. That is simple inverse, in the sense if there is a plus you need to take minus, if there is a suppose if there is a multiplication you need to divide. That's inverse concept, that's conjugate. Now this is simple. 1 by 2 plus root 3 multiply by its conjugate. Conjugate of this concept, 2 minus root 3 divided by 2 minus root 3. Yeah, hope you see. Yeah, 1 into 2 minus root 3, 2 minus root 3. This is, if you get this, the whole concept is done. The left part is mathematics. Multiply 2 into this term, 4. So you can do, if you are lacking the ideas, you will do like this. 2 into this term 4, 2 into this term minus 2 root 3. I will tell you why. Now 2 root 3 into root 3, 3 square and square root cancels, 3 remains. What is this? 2 minus root 3 plus minus cancel, 4 minus 3 1. I will show you the another way. You will get all, in all of your problems you will get this, and you need to remember this. The thing is, if you have an idea, if you are good at maths, you will be observing something here, that's a plus b into a minus b. If I do in that way, see, the same thing is given. I am writing here 1 into this thing gives root 2 minus actually root 3. Now a plus b into a minus b, a square minus b square, a plus b, a minus b, a square minus b square. Same thing, a square 4, a is 2, a square is 4, minus b square, b is root 3. On squaring, square root cancel, 2 minus root 3, 4 minus 3, 1. Everything is same. You need to have an idea, or you need to do this multiplication. Clearly you should take care of all these signs. Sign that is positive or negative. Solving this question, see, there is a 2 problems left. I will solve both the 2. Everything is easy. 5 by root 3 minus root 5 into rationalizing factor, that is nothing but root 3 plus root 5, root 3 plus root 5. See, as I did in this problem, everything is easy. 5 into this number, what? 5 root 3 plus 5 root 5. 5 is outside. Why? Because 5 doesn't has root. If 5 has root, then you can go with the form root ab. Then it will be root 15. Now easy. Now a minus b into a plus b, same, a square minus b square. A square root 3 square is 3 minus root 5 square. That's root 5 square, square and 5, square root cancel, 5. Now you can see here 5 root 3 plus 5 root 5 divided by 3 minus 5 minus 2 is your answer. But in your textbooks they had took this 5 and root 2 outside. They took common, that is, you can take 5 common here. Without multiplying, you take 5 into root 3. See, this steps makes you clear. Root 3 plus root 5. This is given as answer. Nothing. If you multiply 5, you will get this. And 2 into, if there is nothing here, divided by 1, that gives you same thing. That's the second answer. If you have any doubt, please, comment section is open for you, calling it for you. Where are the doubt seekers? 3 root 2. Question. Next, multiply with rationalizing factor or a conjugate. Take inverse. See, everything is easy. Same. 1 into something is something itself. A plus b into a minus b. A square, 7 square, 49 minus b square. See, b here is 3 root 2 square. I will tell you. A root b square is a square into, that square applies to both. Square goes to b, square goes to, square goes to a, square goes to b. A square we give to a, b square. Root b square. Square root cancel. A square into b. Here the same thing. 7 minus 3 root 2, whole divided by 49 minus a square b, 9 into 2. This remains same, 7 root 2. 49 minus 9 into 2, 18. 49 minus 18 is your denominator. 7 minus root 2. And what's 49 minus 18? 9 minus 8 is 1. 4 minus 1 is 3, 31. This is your answer. This completes your 1.5 exercise, not exercise, example part. I am going to deal the exercise part later. Yeah, hope everything is fine and hope you are good at your home. And I have a positive request for you. If you can understand this concept, please share among your friends. What I wish is you share to A, share to B, share to C, D, E, F. Share among your friends so that they can learn, they can help you, you can help them. Even if there are more competitors, your knowledge will be sharp. Please share among your friends so that they can also learn. Share to everyone and keep supporting for us. Please comment on us if you appreciate our work, and if you have any doubt, please comment on us. Bring to our notice that you have that particular doubt and we will clear that. This I am concluding at this point. Thank you. Love you all.